Now let us proceed with the second one, which is how to obtain the angle between a line and a plane. Let's say we have a line L where this line is intersect the plane pi. So our plane is denoted as pi and the line here is L. So this is line L, where this line L has a vector that is parallel to line L. Okay, we know that for every plane, we have a normal vector that is orthogonal to a plane, where this normal vector is denoted as n. And this plane is 90 degrees from the plane. So now we have the graph something like this, the figure something like this. So from here, we know that the angle between this normal vector and vector v, we denote this as alpha. So we have here cos alpha is equals to the dot product of v dot with the normal vector of n divided by the vector of the magnitude of v times with the magnitude of normal vector n. Okay, now we have this formula which is cos alpha. So then, by our aim is to find the angle between this line and a plane, where the angle between a line and a plane is denoted as theta. Since we have here is 90 degree, we know that for the angle of a triangle, it is equals to 180. So since this is the right angle, so what is left is that alpha plus theta is equals to 90 degree, or we can write it as pi over 2. So now our theta is equals to pi over 2 minus alpha. Then we use the sine theta here, where sine theta is equals to sine pi over 2 minus a. So using the identity matrix, so I just rewrite here, sine theta equals to sine pi over 2 minus alpha. So if we expand this or using the identity trigonometric, we will have sine pi over 2 cos alpha minus with cos pi over 2 sine alpha, where we use this formula sine x minus y is equals to sine x cos y minus cos x sine y. So this is from this formula. Okay, sine pi over 2 will be equals to 1, and our cos pi over 2 is equals to 0. So what is left is that we know that sine theta will be equals to cos alpha, because this will be 0. So what is left is just cos alpha. Since we already know the cos alpha here, so we just substitute our cos alpha, which is equals to this, into this formula. So we have our sine theta equals to v dot normal vector divided by the magnitude of v times with the magnitude of the normal vector. So this is the formula to get the angle between a line and a plane. Now let us proceed with example how to find the angle between the plane underline this. So we write our plane, the equation of plane is 3x minus 2y plus z equals to 5. And our line is given x minus 3 divided by 2 equals to y plus 2 equals to z minus 3 over 3. So what we need to do first is that we need to identify the normal vector of the plane and also vector v. Normal vector and v, where this normal vector is taken from the plane, and v here is the vector that is parallel to a line. Okay, now to identify this is just a simple one, where this will be our n, where we take from the equation of the plane, where these constants are the normal vector. So we just write this as 3 minus 2 and 1. And then we know that this is the equation of line. So for equation of line, we know that x minus x naught divided by a. And this is y minus y naught divided by b equals to z minus z naught divided by c. So x naught, y naught, z naught is a point that lies on the line, and ABC here is the vector that is parallel to line L. So our main concern here from this equation is that our value of ABC, where this is the value of vector. So the vector here will be equals to 2, negative 1, 3. So we can just straight away take 2, negative 1, 3, because all the value of x, y, and z here is times with 1. Okay, so since we have the value of normal vector and the vector, what we need to do is we have to substitute into the formula of the angle between plane and the line, where the formula is equals to sine theta equals to v dot n over the magnitude of v times with the magnitude of n. So our dot product of v dot n is equals to 2 minus 1, 3 dot with n, which is 3 minus 2, 1. So we have 2 times 3 plus negative 1 times negative 2 plus 3 times 1. So we have 6 plus 2 plus 3, and we have equals to 11. Then find the magnitude of v. So we have 2 square plus negative 1 square plus 3 square. So we have 4 plus 1 plus 9, which is sec 14. And the last one is the magnitude of n, which is 3 square plus negative 2 square plus 1 square. So this is also equals to sec 14. So substitute all this value of dot product and the magnitude into the formula. So we have sine theta is equals to 11 over sec 14 times with sec 14. So our theta will be equals to 51.79 degree, or we can write it as 51 degree 47 minutes.